Hello everyone. So continuing with our design pattern series, in this video we will cover command design pattern. So let's get started. So in this video we'll start with what is command pattern, why we use it, how to achieve it, its code implementation in C++, and finally its benefits and disadvantages. So let's start with what is command design pattern. So first of all, it's a behavioral design pattern. Now what it does is, it turns a request into an object that contains all info about the object. So now this looks little weird, that how do you turn a request into an object, but we will see it in a minute, right? And then by turning a request into an object, what you can do is you can pass the request as arguments to any function, right? You can also store it in a queue for future execution, right? For async execution. So these are all the advantages when you convert a request into an object. Now, along with these advantages, we have to see why we really want to do it in the first place. So we come to directly why I use command pattern, right? So we will take a very simple example. So consider a scenario where you have multiple appliances, multiple smart appliances at your home, maybe smart TV, smart radio, some other smart devices, and you want to control all of those devices with a single remote. Let's call it a smart remote, right? So now what are the options we have? We have a single remote and we want to control all of our appliances. Now one simple way is to use different set of buttons for each device. Right? For example, you have TV have, let's say, total 10 operations. So you have 10 buttons dedicated to a TV. Then maybe for radio, you have 5 buttons dedicated. For other appliances, you have some buttons dedicated and so on. But as we can see, this solution doesn't scale well. You cannot add new devices on demand, right? So you need to have more buttons available if you want to add new devices, or if you want to control those new devices with the existing remote, right? So as we can see, having different buttons for each device does not scale, and it doesn't also make sense, right? You'll need to have a lot of buttons on your remote, which doesn't make it smart at all. So the second thing which comes to mind is, can't we have same buttons which can control all the devices, right? So consider a scenario where you can, let's say, pair your remote with any of the device, and then all of the buttons work for that device. If you pair it with your TV, now the turn on, turn off button in the remote does perform the operation on the TV. If you pair it with radio, it works on the radio. So that looks like a wonderful solution. But how do we achieve that? How, when you press a button on a remote, how it can issue a command to a TV, and sometimes it can issue a command on radio. So it means there is some sort of interface we need in between the remote and the device, right? So we have to decouple sender from the receiver, right? With this way we can have flexibility and extensibility. For example, the same button now can be used for new devices if you want to do. So what we have established is that the sender is the remote, receiver is the device. We need to decouple them. So we need an abstraction between them, and that is what command design pattern do. So how to achieve it? So let's say you have a remote control and it wants to issue a command, right? Let's say turn on the TV or turn off the TV or any other device. So instead of knowing which device, right? So we decouple it using a command interface. So the remote control only stores a command object, and when you press any button on that remote, it just issues the command with that object. So basically, for that we need a common interface. So we create a common interface command, and it has an execute function. So all of its implementation need to have execute function. So now when you press the button, you just execute the you just call the execute function of the command object. Now let's see what type of command we can implement. So for example, let's say we have a turn on command class which implements this interface, and it stores a device in it, right? So this device can be a TV, this device can be a radio. Based on that device, it will do the execute in that device, and the operation will be performed on that device only. Similarly, turn off device, and let's say there is a command called adjust volume, and let's say it only works for radio. So it also has a flexibility that it can only store the radio. Rather than any device, you can specify that okay, it will only store a radio, because this command makes sense for a radio. Similarly, maybe change channel command, it only works for TV. So now we can see, since you can have multiple devices in any command, we again need a device interface, and let's say it has turn on and turn off function to be implemented. So any device must have at least turn on, turn off functionality. It can have further other functionalities of its own. For example, TV, turn on, turn off, and then change channel as well. Similarly, radio, turn on, turn off, and adjust volume. So now let's take an example of an adjust volume command. It stores a radio. When command pattern, when command object does, like when you press the button, we do the execute of that command. So this execute function will be called, and this execute function will do what? It will call radio dot adjust volume. So when it does a radio dot adjust volume, since the device was radio, the radio volume will be adjusted. Similarly here, if you have a TV device stored, because device is an interface, if you have a TV stored, when you do execute, you will call the turn on function of TV. If you have a radio here, you will call the turn on function of radio. So this way we have decoupled the device with the remote control using the command interface. So I think now we can go to the code. All right, so let's come here. Now we can quickly see what the command looks like. So we create a command class. It's a virtual class because it has only one function execute which needs to be implemented. Now we have like bunch of commands. Turn on command, it takes device as an input in its constructor and it overrides the execute function. Similarly, turn off command takes device as input in constructor. Adjust volume takes radio, and change channel takes TV. If you now look at the implementation of execute, turn on command just issue the turn on function of that device it has. It doesn't know which device, it could be a TV or a radio, just the device. Similarly, turn off the device, adjust volume of the radio, and change channel of the TV. Now we can quickly look at the devices also. So here devices again is an interface, because we know in C++ there is no interface keyword, but by making all the functions virtual, you in turn makes this class as interface only. Now you have a TV which overrides turn on, turn off, and it has its own function which is change channel. Similarly, radio, if we quickly look at their implementation, turn on TV, let's say turn the TV on. Right, and we are just outputting, but here you can have the main logic of turning on the TV, turning off, right, and changing channel and so on. Now we can see all of it together in a remote control. So now we create a remote control class. It has only two functions, set command and press button. So by set command, you can pass any command to it, and by press button, when you do the press button, it will execute that command. Right, in this case, in our remote only one button is present. Right, let's say if you have 5 buttons in the remote, you can have 5 commands present here. Each command can be set with a different command object, right? Maybe turn on command, turn off command, adjust volume command. So all of the commands can be here, but for simplicity we have taken only one command. Now let's say you create a TV, you create a radio, you create bunch of command objects. Turn on TV, turn off TV, you pass TV here. Adjust volume radio, you pass radio here, and change channel TV, you pass TV here. Now you create a remote control, and then you, let's say, set the command as turn on TV. So now when you press the button, TV will be turned on. Here when you press the button again, TV will be turned off, and so on. So we can quickly see this. As you can see, by pressing this button, it turns on the TV, turns off the TV, volume adjusted, and channel changed. So you can pass any command, you can store any command to the remote, and when you do the press button, that command will be executed. So you can see, right, it's very simple. You can pass any object at runtime. Once you have created the remote, let's say a new device comes into the picture, you create new set of commands, and then you can set the remote with those commands, and remote will operate on that new device. So this is how your command pattern works. Now let's come back to the final benefits and disadvantages. So let's look at benefits. Now you can see, since a command is turned into an object, right? When you issue a command, you basically call a function. To call a function, we are basically coupling the caller and the receiver, but with the command you store the command object, and command object takes care of calling the device. So since you have converted a command into an object, it can be passed as function arguments as we did. It can be stored inside other objects, so you can have sort of nested commands also, right? If you want, if you have a more complex use case, you can also switch linked commands as runtime. As we have seen, we can set different commands, and by pressing the button different operation will happen. We have decoupled classes that invoke operation from classes that perform operation. It is a very good thing. It's also it also is a single responsibility principle, right? So the class which is invoking the operation, which is the remote, it wants to perform that operation, and the class which actually perform that operation, which is a device, are now two different. They're decoupled, and new commands can be easily introduced. We already know this. Now let's come at disadvantages. Very few disadvantages. Like we can see, code may become more complex due to abstraction layer, but it is very much needed in the given scenario we just saw. And there is also performance overhead. Now what is this? Now if you quickly see, previously when you had a remote, you can directly issue any command. It will call that particular function and the command will be executed. But now in this case, this command will execute. For example, when you issue the command, it will say, okay, this is of type adjust volume. So you will do the execute function of that. Now that execute function will do the adjust volume function, will call the adjust volume function, and then finally the volume will be adjusted. So you can see there are multiple hops here before reaching the adjust volume, versus where you can perform the adjust volume direct from the remote if this abstraction was not there. So if you have a performance critical use case, then this might not be the way to go, and you may have to tightly couple the sender and the receiver for faster response. So that's it about the command design pattern. I hope this video will help you to understand it. It's not a difficult pattern, but we have to understand it somehow, and that I think a smart remote example fits well. So that's it with this video. I'll continue making design pattern videos, and if you like this video, you can like this video really. And if you want to see more videos, I've already made a lot of videos. You can watch them out, and you can subscribe to the channel for if you want to see future such videos. Thank you everyone.